Okay, we're recording now. So today I was planning to give you your first participation problem. It's not graded. I want you to at least try it. I want you to get a chance to try some problem without the formality of quiz or test or something like that. Okay, so let me try to get this started here. Oops, let me check something. Okay, yeah, we're recording. Share the screen again. Okay, so we are here. So on paper, I was only supposed to do 1.1, but I'm going to finish 1.1 today, and I'll get started with a little bit of 1.2. So I'm slightly ahead. Okay, and even if I fall behind, we have a couple of buffer days. Okay, now when you see buffer day, it doesn't mean it's a holiday. Doesn't mean don't show up. I always put buffer days in case something goes wrong. I get sick, my computer goes down, I fall behind. Okay, so buffer day is not a holiday. Okay, flex day is a holiday. Thursday, 4/22, that is a semi-holiday. Well, I have to work, but you guys don't have to. Okay, so I'm a little bit ahead. So I'm going to finish up the rest of 1.1. Okay, I got almost to the end, and then I'll sneak in a little bit of 1.2. Okay, now, so I won't lecture the entire time today. For the last 10-15 minutes, I will give you a problem to do, and you just type the answer in the chat. Now, I'm going to contradict something I said earlier, maybe. Okay, everything you do, you should show all your work, except for this, mini participation assignment. You can just give me the answer for this one. Now, when you turn in the homework, show me all your work. When you submit the quiz tomorrow, show me all your work. When you submit exams, show me all your work. Okay, only for an in-class assignment, you don't have to show me your work. Just type it in, because you really can't put too much work in the chat, obviously. So you just type your answer in the chat. Okay. For those of you who took me last semester, you might say, "Hey, we didn't do that last semester." You're right. This is new, so I'm doing it. This is this semester, and last semester was last semester. Okay. Now tomorrow, at the end of class, I will give you a quiz again. And again, those of you that had me last semester, this is also different, but I thought I told you already before in previous emails. So maybe the last 10-15 minutes, I will stop, give you the quiz question. So I don't know why it turns yellow on me sometimes. So I will give you a question or questions. I'll show it just like this. So you can either take a picture on your cell phone, or you can take a screenshot or whatever. Okay. I'll set you into your breakout groups. Your breakout room will have 3 or 4 students. Okay. So everybody turns in the quiz. Everybody put your name and everybody in your breakout group. So let's say there's 4 of you. You put your name and you put the names of everybody else in your group. It's up to you if you want to show your video or not. I mean, I personally think it's kind of weird if you're chatting together and working out and you can't see anybody. I mean, it's almost like, to me, like you're blindfolded like this and you're talking to everybody or something like that. But be that as it may, I understand you may not want everybody to see what's behind you and all that stuff. So, as you can see, I don't have anything for you guys to see either. All right, so it's due by the end of class. So that means you have until 10 o'clock to finish the quiz, and everybody submits their own quiz. So all 3 of you or all 4 of you in the group put all of your team members' names, and you all just get out your cell phone. So, click, show that. Okay. I will decide to grade only one person's quiz, and you're all going to get the same grade. Now, I may casually look at all of them. So if it looks to me like, hey, it looks like the same person wrote all 4 of these, then maybe, Ms. or Mr. Straight A student just, wrote it and gave it to everybody else. No. So your object is, if you got the answer right, you have to try to get everybody else in your team to write the same thing. So then that way, it doesn't matter which of you 3 or 4 that I choose, then you'll still hopefully get full credit on the quiz. Okay, so that's the way quizzes work. Today, it's all individual. You just type in the chat what you think the answer is, and that's it. You can always ask me or Prasanna for help as necessary. Okay. Oh, by the way, when you type in your answer, and by the way, I'll stop after maybe 10 minutes or 15 minutes at the end. When you submit your, it's not even a quiz. When you submit the participation, you may leave after that. Okay, that'll be it. You can leave your so-called pass. You know how in high school they used to give out passes, right? Your pass to leave is that you answer the participation, in which case you can leave after that also. Okay. Now, when you submit today, the participation, please send me a private chat. If you make it public, then anybody else can just look at it and type the same thing, right? Okay, so send me a private chat. The answer is blank. But if you make it public, the answer is blank. Then all anybody else has to do is just look at what you typed and just type in the same thing. So I don't want that, obviously. Okay, so that would help me tremendously with that. Okay, so that's the way it's going to work. So I will finish 1-1 and start some of 1-2 today. Okay, so that's where we're headed. Okay, let me check the chat real quickly because I know some of you put this. Is the quiz tomorrow on 1.1 and 1.2? Yes, it is. And let's see. When we turn it in, do we email? Yes, just email me your response. So just get out your cell phone and click, click, click. Okay, and Prasanna will be there to help tomorrow and today. Okay, the most likely scenario is if you need help on the quiz. Okay, and I say quiz, you should really think of it as an in-class assignment. Okay, it's not what you normally think of as quizzes. You can help each other out. You can use your book. You can use your note. You can talk to each other about it. Okay, but frankly, it's a little bit harder for me to keep writing in-class assignment. That's like 15 or 20 letters. But if I just say quiz, that's only 4 letters, right? So I call it a quiz. It's only a quiz in quotes. In my opinion, you don't even have to prepare for it or study for it because you can use your book and notes and talk to each other. And Prasanna and I will help too. Now, what normally happens on quizzes is Prasanna will go around to different breakout rooms to help. I will normally stay in the main room. So if you want to come and catch me in the main room, you can. But I will sneak into various rooms also, as the case may be. And then just send me an email. Okay, my email is on the syllabus, right? homm@smccd.edu, right? And maybe I'll just show it to you one more time. Yeah, here we are. homm@smccd.edu. By the way, a quick word of note to avoid confusion. My last name is actually Hom, H-O-M, not H-O-M-M. Okay, the standard for CSM is last name and first initial, right? So my last name is H-O-M. My first name is Melvin, so there's an M there. So anyway, so my last name's not H-O-M-M, it's H-O-M. Anyway, to avoid confusion for that. So my first name was John, it would be H-O-M-J at SMCC. Anyway, so that's that. I'm not overly irritated if you get my name wrong. I've got it. I've got my last name is called Ham before H-A-M and other various things, but be that as it may. All right, so I'll turn that off. Okay, I can't see the chat, but you can still put stuff in the chat, and Prasanna will help me with that. Okay, so there are a couple of problems at the end that I wanted to show you, and then I'm just about finished with 1.1. We can get back to that. Okay. So we were doing a lot of this stuff, right? So the last thing I did was that equilateral triangle, which was 59. Okay, so let me show you another one, 61. I'm trying to raise it up, but the book's heavy. 61, an open rectangular box with volume 2 meters cubed has a square base. Express the surface area of the box as a function of the length of the side of the base. Okay, so I have to put the book down because it's heavy. All right, so here's the picture. You have a box. So I drew a little box here. Okay, the base is a square. Okay, so that means if this is X, but it doesn't say this side is the same, so I'm going to call it Y. Okay, so X by Y. Okay, now it said the volume was 2 cubic whatevers. What was it again? Cubic meters? 2 cubic meters. Okay, how do you find the volume of a box? Well, length times width times height. Okay, a box, it's just a 3-dimensional analogy of a rectangle, right? If you have a rectangle, it's length times width. Just add the 3rd dimension, then volume is length times width times height. So it's X times Y, X squared Y, and that has to equal 2. Solve for Y. Divide by X squared. Y is equal to 2 over X squared. Okay, so now we want an area function to ask, how do I find the surface area? Now, it says it's open. That means there's no top, there's a bottom, and you have the four sides. So can you visualize such a box? Right, you've all seen boxes, I'm sure. Okay, so this box has no top, bottom, four sides. Okay, so what's the surface area? There are 5 sides, right? There's the front and the back, left and the right, and the bottom, but no top. So what's the area of the bottom? X squared. What's the area of the front? Well, x times y. How about the back? X times y. Also the left and the right are also x times y. They're just regular rectangles. There's 4 of them. So x squared plus 4xy. Okay, that's the bottom. That's the 4 sides. Right, the bottom is x by x. The front, back, left, and right are all x times y. So 4xy. Okay. But what's y? Y is 2 over x squared. So I just pick this up and plug it right into here. So I get x squared plus 4xy, and here's y, 2 over x squared. Okay. Then I just clean that up a little. Looks like this x can cancel that x. 4 times 2 is 8. So final answer is x squared plus 8 over x. Okay. So the surface area of this box can be written as a function of x. You give me the x, here's the surface area, x squared plus 8 over x. Okay, so that's all. All right, problem's finished, but quick little timeout. Just think to yourself, you don't have to answer, you don't have to unmute yourself or put it in the chat, but just think, suppose it did say there was a closed top. How would this problem change? You would have 2x squared because the top is also x squared, is it not? So if you had a closed box, this was an open box. If it's a closed box, well, there's another x squared. So the only difference would be a 2x squared here and a 2x squared here also. Okay, so that's all. All right, and then the last part of section 1.1 is a review of even and odd functions. Okay, which means after I do that, I'm finished with the section. Okay, so I've done quite a bit of this, as you know. So, I say you're responsible for this homework, but what have I done? I've already done, I don't know, half, sometimes more than half, sometimes less than half, but a lot. Okay, so 73 to 78 all involves even and odd functions. Determine whether the function is even, odd, or neither. Okay, so a quick review of that. I will do the even ones because you don't have the even answers in the back of the book. The odd answers are generally in the back of the book. Okay, so a quick review of even and odd functions. Okay, given a function f, a function is even by definition if f of negative x is the same as f of x itself. Okay, by the way, remember you're allowed to have one cheat sheet. Okay, you have to decide for yourself. Okay, you get one sheet of paper, right, standard size, 8.5 by 11. You can write in the front and the back, 8.5 by 11 paper. If you want to put that on your cheat sheet, you may, but obviously you can't put everything on your cheat sheet, so you kind of have to budget your paper, so to speak. Okay, f is even if f of negative x is the same as f of x. So to determine even, odd, or neither, you replace x with negative x. If you get the same thing back, it's even. If you get the opposite of the original, it's odd. And if you get neither, it's neither. Okay. Here are some examples of even functions. X squared, x to the fourth, absolute value of x, cosine x. Okay, if I replace x with negative x, okay, what is negative x squared? Well, it's the same thing as x squared. That makes it even. Likewise, what's negative x to the fourth power? Well, that's the same as x to the fourth power. Okay. The absolute value of negative x, that's the same as the absolute value of x. Okay. And you may or may not remember this from trig, but cosine happens to be even. Cosine of negative x is the same as the cosine of x. So for instance, cosine of negative 35 degrees turns out to be the same as the cosine of 35 degrees. Okay. And by the way, you can see a very good reason why they call it even. If you have power functions, right? X squared, x to the fourth, 6, 8, 10, those are all even. So that's the reason why it's called even. Although by this definition of even, there are functions that are even that don't look like this. Like here's an example, right? That's even, although it doesn't look like that. Okay, odd functions. If you replace x by negative x, you end up with the opposite of the original, the negative of the original, then it's called odd. And again, you can see obvious reason why. X cubed. What happens when you replace x with negative x? Negative x cubed, negative x times negative x times negative x is negative x cubed. So what do you get? You get the opposite of the original. So that's why it's called odd. Likewise, negative x to the fifth power is the opposite of x to the fifth. Okay, so you can see if I have x, by the way, x to the 1 also works. F of x equals x is also considered odd. X to the 1, 3, 5, 7, 9, those powers are odd by definition because you have odd powers here. But from this definition of odd, there are functions that don't look like this that are also odd. Sine and tangent are like that. Okay, in other words, the sine of negative x is the opposite of the sine of x. So on your calculator, okay, if you would have tried the sine of, I don't know, pi over 12, and you tried the sine of negative pi over 12, they'd be the exact opposite. Okay. Same thing for tangent. Okay. Tangent of negative pi over 5 is the opposite of the tangent of positive pi over 5. Okay, so how do you do those problems? So I will do the even ones, 74, 76, 78. Okay, 74, f of x is x squared over x to the fourth plus 1. Maybe I'll just start off with this. Okay, well, you can already see the answer. Okay. Can you guess whether this would be even or odd? I mean, even if I didn't just run over this definition of even and odd, and you said, I have no idea what an even and odd function is, what would be your guess if you saw, all you saw was x squared and x to the fourth plus 1, right? You say, oh, that's even, maybe it's even, okay? But how would you formally prove that now? Okay, and by the way, you are supposed to show me this on homework, quizzes, and tests. Don't just say it's even because I think it's even or whatever, okay? So how do you prove it? So to prove it, you replace x with negative x. So you plug in f of negative x. Okay, so right here, you put negative x squared, negative x to the fourth plus 1, like that. Okay. Then you work it out. Of course, we know negative x squared, negative x times negative x is the same as x squared. Likewise, negative x to the fourth power, negative x times negative x times negative x times negative x. There's 4 negatives, so it's x to the fourth plus 1. And what do you notice? It's the same as the original, therefore it's an even function. Okay. So that's how you would prove this is even. Okay, let's try 76. F of x is x absolute value of x. Okay, so how do you know if it's even, odd, or neither? So you replace x with negative x. So right here, make that negative x. Right here, make that negative x. So f of negative x is negative x, absolute value of negative x. Okay. Now, we know that the absolute value of negative x is the same as the absolute value of x, right? So I can rewrite it like this. Okay, so this is f of negative x. Okay, so now compare this with this. How does the new function compare with the original? Look at that and look at that. They're opposites, right? The opposite of that is that. In other words, f of negative x is negative f of x. So by definition, this is an odd function. Okay, and then 78. F of x equals 1 plus 3x cubed minus x to the fifth. Okay, this one's a little tricky. At first glance, you might say, aha, odd, odd, it's automatically odd. Now, that would be true if I didn't have the 1. Okay, well, how does the 1 change it? Okay, so let's just go ahead and go by the definition. Replace x with negative x. So f of negative x, 1 plus 3 times negative x cubed, right? Minus parentheses, negative x to the fifth. Okay, 1 stays the same. Negative x cubed is negative, so negative 3x cubed. The negative of negative x to the fifth is positive x to the fifth, right? Okay, now just go strictly by the letter of the law. Is this the same as this? No, it's not. Okay, watch out. Is this the opposite of this? In other words, if I put negative parentheses, do I get this? The answer is no, okay? Because the opposite of this is this, the opposite of this is this, but you still have 1. Okay, so the negative of this or the opposite of this is not this. So this one would have to be neither. Okay, so it's a little bit tricky, so you have to watch out. So just go by the letter of the law, so to speak. So at first glance, you might say, I'm pretty sure it's odd. No, this is not odd. Okay. Now, if you really want to dig super deep into this, okay, 1, is there a way you can write 1 as x to a power? The answer is yes. 1 is x to the 0, right? So if I wrote this as x to the 0, you would say, oh, there's a 0, which is not odd. 0 is considered even. So it's a mixture of even and odd. Okay, if you pretend this is x to the 0, right? Because x to the 0 is 1, say, oh, there's an even and odd. So that means it's probably going to be neither. And that happens to be the case here. Okay. All right, so that takes care of that. All right, and I am now done with 1.1, folks. Okay, so I'm finished. I'll start some of 1.2. My original goal was to only do 1.1 up to today. So we're just getting a little bit ahead of schedule now. Okay, so I'll do some of 1.2 as an introduction. I will go ahead and check the chat. Some of you put something in the chat. So let's see. How do you know what to plug in? Okay, so you will plug in. So this is exactly what you do. Okay, now what Prasanna has is correct also. You have symmetry, but just for evenness or oddness, just replace x with negative x. Okay, and if you get the same thing back, like over here, it's even. If you get the opposite of the original, then it's odd. And in this case, it'd be neither. Okay, and yes, Prasanna did mention some symmetry about that. I'm not going to go over that now. What he says is correct, but we'll talk more about symmetry a little bit later. Okay, but I'm going to get started with the next section. You can go ahead and keep putting stuff in the chat, and Prasanna will help me with that. Okay, but 1.2, okay, a review of essential functions, so to speak. Okay, the homework is not really that long. 1 to 9, all, notice it's all, A-L-L. So I'll try to help you with as many evens as possible. Then 11, 13, 15, and 17. Okay, and as I promised you, in case you never want to buy the book, I'll show you the important pages. Okay, since we're recording here. Okay, linear models on page 24. Okay, we know what that looks like. Y equals f of x equals mx plus b. Sorry, I don't have, I'm holding up the book, so I can't point it out to you. If I had a third appendage, I could point it to you, but y equals mx plus b, f of x equals mx plus b. We know that's a straight line, right? Okay, on page number 27, polynomials. Okay, so here's a formal definition of a polynomial. P of x is a sub n, x to the n, plus a to n minus 1, x to the n minus 1, and so on. That has degree n. The a's are the coefficients, right? The largest exponent that you see is the degree. So look at the polynomial they have there. I can't point it to you, but P of x, 2x to the 6 minus x to the 4th plus blah, 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 right? That's a polynomial of degree 6, 6-degree polynomial. Okay. Quadratic function is second degree. So see where it says P of x equals ax squared plus bx plus c. That's a quadratic function. You use it to solve the quadratic formula, right? Quadratic formula looks like ax squared plus bx plus c equals 0. Okay. At the bottom there, degree 3, ax cubed plus bx squared plus cx plus d. Okay. That's sometimes called a cubic, C-U-B-I-C, a cubic function. And there it is. It's called a cubic function, right? And they show you some graphs. We will be graphing a lot of these. Now, you graph a lot of these in pre-calc, hopefully, but we're going to learn neat stuff like on the graphs. How do you find that maximum point and that minimum point that I can't show you? I'm going to put the book down just for a moment so I can point. Okay. Maximum point, minimum, maximum, minimum. Okay. You didn't know how to do that in pre-calc, but we're going to know how to do that in calc, which is really neat. One of the nice features of calculus. Okay. Power functions, page 29. Okay. So figure 11, you see y equals x squared, x cubed, x to the 4th, x to the 5th. They all tend to look the same. Okay. You notice that x cubed, and x to the 5th pass through which quadrants? X cubed, x to the 5th, quadrants 1 and 3. Okay. Look at x squared, and x to the fourth. What quadrants do they pass through? That quadrant 1 and 2. Okay. And these are even functions. I'll just mention it quickly, but Prasanna was putting this also in the chat. If you look at y equals x squared and y equals x fourth, they both have symmetry with respect to the y-axis. Okay. If you look at y equals x, x cubed, x to the fifth, they have symmetry with respect to the origin. Okay, which means, for instance, 1, 1, you reflect across the origin, you get -1, -1, right? Same thing here. Same thing here. Okay. All right. Square root function. Hopefully you've seen this in pre-calc. Where am I on page 30 now? Square root function. Look at the domain of the square root function. Looks like all I have is the origin and first quadrant. Well, that makes sense because, again, we're not doing any imaginary stuff. We're not doing any of the I business, square root of negatives. Okay, so if f of x equals square root of x, I'm not allowed to plug in negatives. That's why there's no graph over here. And the answer that comes out can't be negative. So there's no graph here. So there's no graph in quadrants 2, 3, and 4. Okay, and square root function looks like this: 0, 0, 1, 1. If I plug in 4, I get 2, and so on. However, look at the cubic function, x cubed. Can you take the cube root of a negative number? Yes, you can. So the domain of the cubic function is all real numbers. The range is also all real numbers. Okay? So for instance, can I take the cube root of -1? Yes, that's -1. So it's over here somewhere. Okay? In fact, it looks like this function is odd. It does have symmetry with respect to the origin. So there we go. Okay, the reciprocal function, do you remember y equals 1 over x from pre-calc, hopefully? Okay, so y equals 1 over x looks like this and like this. I'll try to hold it up for you. Okay, for the domain, it looks like all real numbers except for 0. Same thing for the range. And is that obvious from the function? You're not allowed to plug in 0, otherwise you'll be divided by 0, but you can plug in anything else. Okay. And looks like it's an odd function. If I replace x with -x, I get the opposite of the original. Okay, rational functions. These are pretty bad. We're going to graph some of these. They're pretty bad graphs. Okay, rational, think of it as ratio. If you cover the last 3 letters, it looks like ratio, right? So rational, ratio, it's a ratio of 2 polynomials. Polynomial divided by a polynomial, like this. Okay, they are generally very difficult to graph. We're going to graph some, but they could be a real headache. Okay, they might be some of the most difficult ones to graph. And then they just say algebraic. You got a mixture of all kinds of stuff, square roots and cube roots and, you know, all kinds of other stuff mixed together. So they just call it algebraic. Okay, trig functions. Well, you know it's trig if you see sine, cosine, tangent, secant, cosecant, cotangent. Right. So there's a review of the sine graph, cosine graph. One thing that you'll want to recall from trig, okay, what's the range of the sine function? What's the range of the cosine function? How high and how low? -1 to 1. The domain is all real numbers. I can take the sine of any real number. I can take the cosine of any real number. So in other words, on my calculator, you type in any real number, I can take its sine, I can take its cosine. But the only numbers that are going to come back are stuff between -1 and 1. Okay, sine is between -1 and 1, cosine between -1 and 1. And you can see that from the graph. Okay. By the way, that's not true for tangent. The tangent of angle can come out to be any real number, as it turns out. All right. Okay. Exponential functions. Okay. And by the way, you might say, I'm sure going fast. Yeah, to a certain extent, it's just a review. This should not be brand new. Okay. I'm not introducing this for the first time, hopefully. You've seen all this before somewhat. Okay, so exponential function, like 2 to the x, half to the x. Okay, 2 to the x goes up, 1/2 to the x goes down. So if the base is bigger than 1, increasing. If the base is smaller than 1, decreasing. And log functions. What do log functions look like? They tend to look something like this. Okay. Logs have a base, log base 2, log base 3, log base 5, log base 10. Now, in our class, our favorite log is going to be the natural log, ln. So in my calculator, ln stands for natural log or log natural. They put the L first to emphasize that it's a log. Okay, log is base 10. ln is base e. We'll talk more about e. E is about 2.718, something like that. You don't have to write that down if you don't want to. If you just want to memorize quickly something about e, say 2.7, just like pi, right? What do you think of for pi? 3.14 maybe, okay? But there's infinitely many digits. Likewise, e, you might want to know e is 2.7, and that's about it. Okay, so the base for ln is e, the base for log is 10. You really can't forget it because on just about every calculator, they're paired like that. Okay, I've got different calculators here. Show you a more fancy calculator. Whoops. Okay, so yeah, here's ln. Above it is e to the x and log 10 to the x. Okay, we're not going to use log base 10 very much at all. We're going to do ln in this class quite a bit. Okay, so I'll do some problems and then I'll stop after a while and give you something to do in class. Okay, so 1.2, you have 1 to 9, all 11, 13, 15, 17. Okay, just classify the function. What do you call the function? That's all. So it was 1 to 9, all. 1 and 2 look similar. You have the answer in the back of the book for 1. So how about I'll do 2 for you. So just what kind of function is it? Okay, look at 2a and 2b. They look the same, but a is pi to the x. B is reverse, x to the pi. Okay, so this is considered a power function. Okay, so if you want to write this down, 2b is a power function. Sorry, I can't write it, but hopefully you can write it. Okay, this is considered an exponential function. Okay, so if you have a constant to a variable like this, exponential. If you reverse it, it's a power function. Okay, think of this like, it's like x squared, right? Sorry, I can't write, I'm holding up the book. That's like x squared, x cubed, x to the fourth. The only difference is you have a weird exponent, x to the pi. Pi to the x, that's like 2 to the x, 3 to the x, 4 to the x. Those are called exponential. Okay, so pi to the x, think of it as 3.14159, blah, 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 to the x. Okay, so put down this as exponential. Here it is. B was what? B is a power function. Okay, how about C? Okay. Well, if you multiply it out, right, it's 2x cubed minus x to the fifth. That's a polynomial. Okay, so C is a polynomial. D should be obvious, right? Trigonometric. You can just write trig. Okay. You can abbreviate all these if you want. So exponential, you can just put exp. Logarithm, just put log. Okay. This one, s over 1 plus s. Hint, it's a ratio. Rational. Right? So it's rational. F, well, it's got so much junk in it. Okay. We're just going to call that algebraic. That's square root and a cube root and a division. Okay, so F is just algebraic. Okay, so quick review again in case you didn't get it. So this one was exponential, power, polynomial. I guess you could just put poly for me. Trig, rational. You can just put ratio if you wish. And algebraic. Algebraic, just put ALG, I suppose. Okay, let's see. 3 and 4 matching. It says explain your choice. You don't have to explain your choice. It's just what you memorize as a graph. Okay, so just match. Sorry, I got to hold the book up. Okay, A, B, C, D with big F, big G, and little g. I don't know why they do that. Why don't you just pick 4 different letters? But anyway. Oh, 4A should be easy. What does 4A look like? That should be, I think I can organize this. Yeah, that's a straight line. So which one's a straight line? Capital G. So 4A should be capital G, right? B, 3 to the x. That's exponential. So which one grows like an exponential? Looks like letter F. Correct? So that's letter F. And C and D, the cube and the cube root. Okay, so you should know which one is which. So x cubed, cube root of x. So which one looks like x cubed from what I showed you before? That would be capital F. So 4c is capital F. So by elimination, that leaves D to be the only one we didn't do, which is little g, right? So that's it. Okay, so a quick review again. A was which one again? A is capital G. B is little f. C is capital F. And D is little g. Yeah. Okay. All right, so that's that. What time is it? Okay. Find the domain of the function. I'll do maybe one and then I'll stop and give you something to do in class. Find the domain. Okay, g of x equals 1 over 1 minus tan x, number 6. Okay, so let me show you that quickly. One over 1 minus tan x. So the trouble would be the denominator. I don't want the denominator to be 0. Okay, so 1 minus tan x equals 0. I solve that first. So move that over tangent x equals 1, which is sine x over cosine x. So when is the sine and the cosine equal? Well, pi over 4, 5 pi over 4, and so on. Okay. So the way you can write that is pi over 4 plus k pi, where k is an integer. That gets thrown out. So I throw that out. So the domain is all real numbers minus pi over 4 plus k pi, where k is an integer. Okay, so I have that at first. Okay, that's actually not quite it because the tangent function itself, if I just look at tangent itself, it's undefined for certain values. Okay, so I'm going to leave you hanging right there. There's actually more to it than this, but where was the tangent undefined? Okay, you might recall that graph of the tangent. The tangent looks like a bunch of this stuff. Okay, where you had a whole bunch of asymptotes. So you have to throw those out also. Okay, so this is true. Okay, so all real numbers minus pi over 4 plus k pi. Okay, if I just take multiples of pi, okay, that's thrown out because that makes the denominator 0. But I also throw out where the tangent itself is undefined. Okay, so I'll let you think about that for next time. I'm not even sure I'll spend time to answer that, but I'll just leave you hanging there. Okay, so I'm going to stop and give you a problem to do in class right now. Let me check the chat. This persona was there to help me. Okay, yeah, that's fine. Okay, all right, so if you have a question about I can't answer it right now, but you can email me about that. And attendance, got that. Okay, all right. Okay, so in class right now, you can just answer in the chat and send me a private chat. 1.1 problem number, let's see, 77. Okay. Now, work it out on your own, but send me a private chat and just put down odd, even, or neither, and that's your pass to leave if you want. Okay, I can't hold this very long, so either write down problem 77, or if you have the book, just go with it, or take a picture on your cell phone, or take a screenshot, or whatever. I'm going to hold this up for maybe just another 10 seconds because the book's heavy. Just do problem 77. 1 plus 3x squared minus x to the fourth. Okay, is it even, odd, or neither? When you're finished, send me a private chat and then you may leave. But if you want to stick around and ask Prasanna or me something, then you can also. Okay, I'll hold it up just for a few more seconds. Just do problem 77 and send me a private chat. Your answer is either even, odd, or neither. On your own paper, you should work it out. Okay, how do we work it out? Replace x with negative x and see if we get the same thing back or not or whatever. Okay, I know I didn't get to all of your questions. You can come to office hours or send me an email a little bit later. Okay, I'm going to make this disappear. And if you have questions, you can let me know. Otherwise, you can just put the answer in private chat and then you can go. Thank you. Okay, I'm going to stop the share. I'm going to stop recording also. I don't think I have to record anymore.
Thank you.
Thank you.